Newton's cradle works by showing how momentum and energy move through objects when they collide in a straight line. The device usually has 5 steel balls hanging in a row, each held by 2 strings to keep them aligned and only able to swing back and forth. When one ball on the end is pulled back and released, it swings down due to gravity and hits the next ball in line. This collision causes a transfer of force through the middle balls, which stay almost still, and the last ball on the opposite end swings out with nearly the same speed as the first. The reason the middle balls don't move much is because the energy passes directly through them, one ball to the next, in a clean and almost instant path. The last ball flies out, rises, then swings back and starts the process again by hitting the row in the opposite direction. If 2 balls are pulled back and dropped, 2 balls on the other end will fly out, because both momentum and energy are being conserved and transferred in pairs. This keeps the motion consistent with how physics works. This effect happens because of the conservation of momentum, which means total movement stays the same, and the conservation of energy, which means total energy remains in the system unless something like friction or air resistance takes it away. Over time, the balls do slow down and stop moving, because tiny losses in energy build up from air resistance and internal vibrations. Still, for a short time, Newton's cradle gives a perfect view of how force can pass through solid objects without actually moving all of them. Watching the balls click back and forth feels simple, but it's showing a deep truth about how objects interact when they collide, which is part of the laws of motion Isaac Newton first described. The cradle is not just a desk toy, but a working example of physics in action. If you enjoyed the video, give it a thumbs up, comment, and share it with your friends. Don't forget to subscribe to our channel and hit the bell so you never miss a new video.